Hello everyone and welcome back to another video. Today we will be talking about compound interest, which is a topic that you might see in Algebra 2 or even earlier, but in this video we're really going to dive deep into the formula and the components of the formula of compound interest. So it might get a little bit tough in the middle, but I encourage you to pause the video, rewatch the section of the video that is confusing, or you can shoot us an email at exceledlearning@gmail.com if you have any questions. And then at the end of this video, we're going to be doing two examples to help utilize this formula. So stick around if you want some practice. We're going to hit it off right with the compound interest formula. So if we're looking at the formula here, it's A of t is equal to p times 1 plus r divided by n to the power of nt. I know that sounded really confusing and I don't expect you to understand it all right now. Hopefully at the end of this video, you will be able to understand this complex formula. Now we're going to get into breaking it down, so really understanding this formula. The first thing I want you guys to realize is that this is an exponential function as indicated by the nt, which is our exponent, and our base is going to be 1 plus r divided by n. You can also think of it as a to the power of x, with a being our base, x being the exponent, except a is now 1 plus r divided by n. Anyways, let's continue. The next variable we're looking at is p principal, so our variable right here. P stands for principal, and it is the amount of invested money, so the amount of money that you start off with, the amount of money that is first put in to, let's say, a bank or something. So the amount of money that you start off with. Now I know that our variable I doesn't show up in this equation just yet, but in order to get to this complex equation, we're going to have to start off with the more simple equation. So our principal P, the amount of invested money, is invested at an interest rate I per time period. So obviously, I is our interest rate. You're going to be looking for a percent of some sort. Let's say our interest rate was 4%. 4% could also be translated into 0.04. Sorry, that decimal isn't very visible. 0.04, which would also be our interest rate. And then time period. So a time period is how often the interest compounds. So how often, well, that's pretty self-explanatory, how often the interest compounds. So after one time period, our interest is going to be P times I, because we're only compounding the interest once. So we're going to be multiplying our principal, our amount of invested money, by our interest rate, I. So hopefully this is easy to understand, because we're going to get into a little bit harder stuff right now. And just to put this into context of an equation, the amount of A, which is what we're finally getting, like our final amount, also as indicated up here, the amount of A is P, remember our fixed principal, plus our interest, because this is our total interest, our principal times our interest rate. Okay, and then what I did was that I simplified this. So I factored out the p's, which made it p times 1 plus I. Okay, so this is our basic formula that we're going to start off with. So I'll write it out here. A is equal to P times 1 plus I. And remember, this is after one time period. So after one time period only. So it only compounds once. Okay? As we get into more time periods, it's going to be a little bit tougher to understand, but hopefully you guys can stick with me throughout the video. Okay, next we're going to talk about reinvesting interest. So basically more time periods. So our new principal in this equation is going to be P times 1 plus I. So we're basically resetting our principal. And remember, this is our fixed principal, and then this is our total amount that we are getting, our A. Okay? So thus the amount of A after another time period, so 2 time periods now, is A times P times A is equal to P times 1 plus I times 1 plus I. So we have our fixed principal, and then we're multiplying 1 plus I times 1 plus I twice. So we're going to get a total of P times 1 plus I squared, with P being our fixed principal and then 1 plus I being squared. And then after 3 time periods, so now we're going to be multiplying 1 plus I times 3 itself, we're going to get A is equal to P times 1 plus I times 1 plus I. And then we get our time period up here as 3, because we're multiplying it 3 times together. And after K periods in general, so K is going to be just our general amount of time periods. So you can plug in any number for K. We're going to get A is equal to P times 1 plus I to the power of K. So just like we had 3 over here, we can plug in any number for K, and K would represent the amount of time periods our interest is compounding. What I want you guys to recognize here is that 1 plus I is our exponential function base, and K is our exponent in this case. Okay, so hopefully that wasn't too tough to understand. We're going to continue on, and we're going to add more variables. So we're going to add R, N, and T so that we can finally arrive at this complex equation. Okay, so we are introducing R, which is the annual interest rate. So the annual interest rate is going to be a percent again. And then our N is going to be the amount of times interest is compounded per year. So annual also means yearly, so our yearly interest rate. And N is the amount of times the interest is being compounded per year. So how many times in 1 year is our interest being compounded? It can be any time from once a year to twice to 4 times to even daily. Okay. Anyways, this would mean that in each time period, I, so our total interest rate, is equal to the annual interest rate divided by the amount of times our interest is being compounded. So if we look back up here, we have our variable I in this case. Now we're going to be replacing I with R divided by N. And remember, R is the annual interest rate, so yearly. Maybe I should spell it out. Yearly interest rate. And then our N is the amount of time, so number of times our interest is compounded per year. Okay, so this is what we are replacing our I with, our I variable. So this would equal, I is equal to R divided by N. And there are NT time periods in T years. So remember, N is the amount of times that interest is compounded per year. And T is the amount of years. So it only makes sense that our time periods is equal to NT. So how many times it's compounded per year? And T is our amount of years. Okay, so now put together, we are going to take this value, R divided by N, and NT, and replace what we have established. So now we're going to get compound interest is calculated by A of T is equal to P, our principal, times 1 plus R divided by N. This was I, remember, and NT, which was K. All right, hopefully that wasn't too confusing. Let me move this. I'll make it, okay, there we go. But for this, just for the sake of this video, I'm going to erase I and K because I don't want you guys to get confused. These are the variables that you should be using in this case, okay? And just to define some terms, A of T is the amount of money after T years. So let's say you're calculating for amount of money after 5 years in your bank. You're going to do A of 5, and then wherever you see T, you're going to plug in 5. So you're going to have N times 5, and then whatever your N is, you're going to plug that in. Whatever your R is, you're going to plug that in. Whatever your P is, you're going to plug that in. Okay, let's continue on. P is the principal, which we have already established. P is right there. R is the interest rate per year. So remember, per year, our interest rate. N is the number of times interest is compounded per year. So your time periods. T is the number of years. The number of years that we are looking for in the problem. So for example, in 5 years, our interest will be so and so. T would be our 5 years. N would be how many times the interest is being compounded per year in all of those 5 years. One quick note, I don't know if I've mentioned this already, but your R, you're going to see it in the form of a percent, so like 10% interest rate. What you want to do to convert it so that it can fit into this position right here is convert it to a decimal. So you're going to move the decimal place 2 places to the left, so 1, 2. So my new rate would be 0.1. It's the same rate, it's just you want it to be in the form of a decimal when you plug it into the equation. And they're always going to give it to you in the form of a percent, so you're always going to have to calculate it and convert it into decimal form. Okay, so we have finished with our lesson. Now we're going to do some examples just to kind of revise these topics. So I took this problem from the internet. If you want to go check it out, here is the link that you can use. Anyways, how much money will there be in an account at the end of 5 years if $1,000 is deposited at 3% compounded quarterly? Okay, so that was a lot of words. We are first going to define our variables. So remember that P is our principal, so the amount of money that is invested at first. I'm going to highlight all of the important things in this problem. 5 years, definitely important. 1,000, important. 3%, very important. Compounded quarterly, extremely important. And they said assume no withdrawals are made. So assume that nothing is being taken out from the bank account and all the money is still in there. So if you think you can solve this problem right now, go ahead and pause the video, solve it, and then you can check back later to see if you're correct. But if not, let's get right into it. So how much money will there be in an account at the end of 5 years if $1,000 is deposited at 3% compounded quarterly? P is the amount invested at first. We saw that we have $1,000 deposited at first. Our N, remember, is the amount of times it's being compounded per year. So we can get this from the quarterly. Quarterly is 4 times per year. Our R is the rate per year. 3% is our rate. So just look for a percent if you're trying to find R. And remember how I said we always have to convert it into decimal form. So 3% is going to equal 0.03. And then we have our T. So our T is going to be the amount of years we're looking at. So in how many years are we going to see how much money we have? And then we can get that from the 5 years we have here. So 5 years, you can put your units. And now we just plug it into our formula. So we look back up here. We are going to be using this formula that we just broke down. And then I'm going to make this a little bit smaller. So we have our A of T is equal to P times 1 plus R divided by N to the power of NT. Okay, great. So now we can start plugging everything in. Let's start with our A of, and then our T was 5 years. So we're going to plug in our 5. Our P is 1,000. Times 1 plus our R, 0.03, divided by our n, which is 4. And then our n again, 4. And t right here is our 5. 4 times 5. Great. So now you have all the numbers in place. All you have to do is simplify. And I'm going to be using a calculator for this problem, just so that it can be a little bit easier. So a of 5 is equal to 1,000 times, and if you simplify this, you're going to get 1.0075 to the power of 20 if we multiply the 4 and the 5 on top. Now it's going to be super hard to do 1.0075 to the power of 20 by hand. So I recommend just using a calculator. So then we get a of 5 is equal to, and if you decide to simplify this using a calculator, your final answer is going to be $1,161.18. So this is how much is going to be in your account at the end of 5 years with your interest being compounded at 3% quarterly, so 4 times a year. Great, so now that we have this answer, we can move on. If you have any questions about this example problem, definitely email us. If not, we can move on. Our second problem is, if $1,000 is invested at an interest rate of 12% per year, find the amounts in the account after 3 years if interest is compounded annually, semi-annually, monthly, and daily. So we have a lot of components in this problem, which is why I made this chart so that it can be a little bit helpful when we're solving everything. But as we did in the first thing, we're going to highlight all of the important stuff. So $1,000, important. 12% per year, this tells us our annual interest rate. 3 years, so in the account after 3 years, compounded annually, semi-annually, monthly, and daily. Wow, okay, so definitely we have a lot of components. Our P is 1,000, super easy to find. Our R is 12%, or 0.12. Our T is 3 years, and our N is going to vary because now we're compounding annually, we're compounding semi-annually, monthly, and daily. So that's why I have multiple columns for N. So annually means once a year, so we have once a year. Semi-annually is twice a year. Monthly is 12 times a year. And daily is going to be 365 times a year. That's a lot. Okay, so now we can plug all of this stuff into our chart. So our compounding column, so we're going to start off with annually. I'm going to use a different color. So we're starting off with compounding annually. Our N is going to be 1 because we're compounding once a year. And I'm going to write out our formula here. So obviously everything is equal to A of t, but I'm going to start off with this. A of t is equal to 1,000, so our P, times our 1 plus our R, so 0.12, divided by our N, so once, to the power of 1 times 3. And this is our N, this is our T. Hopefully you guys are sticking with me throughout this. I will also write the equation up here so that you guys can refer to it. P times 1 plus R divided by N to the power of NT. Perfect. So now you can just match up the variables. Okay, so obviously I'm just going to simplify this. 1,000 times 1 plus 0.12 divided by 1. So we just have 0.12. Write that out. To the power of 3. Now, if you decide to simplify this by hand, go ahead, but it's going to be a little bit hard, so I just use a calculator. Your final answer is going to be $1,404.93. 93 cents. Okay, perfect. So this is how much is in your bank account after 3 years of interest being compounded annually at 12%. So that was a lot. Final answer. Okay, so now we're going to continue on. Our next is being compounded semi-annually. So semi-annual being compounded. And n is going to be 2 in this case because semi-annual means compounded twice a year. So we're going to do our equation again. A of t is equal to our p, so 1,000 times 1 plus our r, 0.12, divided by 2 in this case, to the power of 2 times 3. I'm only going to simplify the exponent, 1,000 times 1 plus 0.12 divided by 2 to the power of 6, and you can plug all of this into a calculator, and if you find that, you will get $1,418.52. Okay, perfect. So this is our second answer for semi-annual. So all we're really doing is changing the n, so the n variable places. So 1, 1 over here. And this is only changing the amount of times interest is being compounded. And obviously that makes sense because we have tons of stuff here, compounded annually, semi-annually, monthly, and daily. Okay, let's continue on. Next we're going to be looking at monthly. Monthly, this is being compounded 12 times per year. So we can plug it into our formula. A of t is equal to 1,000, our p, times 1 plus 0.12, our same r, divided by 12 in this case, and then to the power of 12 times 3. Our 3 is our t, so after 3 years. I'm only going to simplify the exponent again. 1,000 times 1 plus 0.12 divided by 12 to the power of 36. Awesome. So now if you plug this into your calculator, you will find that your answer is $1,430.77. Wow, okay, and now we are finally at our daily. So daily. And this is being compounded 365 times per year. So our A of t is going to equal 1,000 times 1 plus 0.12, our same r, divided by 365 to the power of 365 times 3. Okay, I'm not going to simplify anything here. It's a lot of work, but plug this into your calculator and you'll find that your answer is going to be $1,433.24. Awesome job. Okay, so this was a lot of work, and I understand that. Hopefully you were able to stick throughout the video. You understood everything. That is the main goal of this video. Now we'll quickly go over what we learned as a brief run through. So first we looked at the formula, which was obviously very confusing at the beginning, but then we went over the individual variables, time periods, then we replaced our I with our R and N, our K with our N and T. Then we finally reached the complex formula, and then we defined all the terms, and then we went over 2 very hard examples, and if you got them both, Great job. That was a little bit hard. Um, so if you have any questions, feel free to email us at exceledlearning. We will be there to answer anything that you have. Please like this video, share it with anyone who you think might be interested, and comment if you have any questions or any future video topic suggestions. Be on the lookout for our upcoming videos that are going to be released on Monday, Tuesday, and Friday. Um, we are excited to make these videos for you. Stay in touch. Bye.